Hello, hi everyone. Welcome to the Student the Brand. This is our Siva sir. Today we are going to discuss about human eye and colorful word. Human eye and colorful word. So human eye and colorful word. So human eye is the most sensitive organ in our body. With eye only we can able to see the object. So if you close your eyes, you can't able to see anything around us. Once you open your eyes, you can see everything in front of us. Everything in front of us, right? So with our eye only we can see the things. That is it. That is the reason human eye is the most sensible and sensitive organ in our body. Today we will discuss about human eye parts and function, myopia, hypermetropia, presbyopia. Those are refractive defects. Myopia, hypermetropia, presbyopia. So after that, we will discuss about refraction through prism. After that, we will discuss about recombination of spectrum of white light. After that, we will discuss about rainbow formation by water drop. After that, advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. So then atmospheric refraction, scattering of light, all those points we'll discuss. So let's start with the human eye. Okay, so how to draw the diagram? Okay, so it is very important. You have to draw the eye diagram. So drawing eye diagram, it's very easy topic, easy task. So we need to learn the diagram, how to draw. Okay, so I'll draw the diagram. Just check once. So if you are taking here a human eye, human eye, human eye and colorful world, human eye and colorful world. Human eye and colorful world is the topic, very interesting topic. So why, sir? Because 5 marks question can be expected from the chapter. Okay, so 5 marks question. That too, we know that important topic also. Like best example, we can say myopia, hypermetropia. So we can identify in easy way. Whereas remaining topic, if you observe, so we can't identify the important, like you can say, important concept. If you take light chapter, okay, so we can observe, we can expect the topics from refractive index and lens image formations and uses of concave mirror and convex mirror, uses of convex lens and concave lens, and sign conventions related problems like this. But in this topic, directly we can get it. Okay, so very simple topic, very easy topic, very interesting topic, that is humaning. Okay, so let's start the topic. Human eye parts and function. We will discuss now human eye parts and function. Right? So I'm drawing the human eye. So you can draw the circle. So first to draw the circle like this. First to draw the circle. So just simple circle. Very simple circle. After that, so this is step 1. You can draw all the steps at once. So I'll draw in one step only. Because if you follow all the steps in exam, it is not good. So you have to follow. Okay, same all 3 steps. 3 steps you can draw in one diagram. Okay, so just check once. I'll draw the diagram. Okay, so I'm drawing like this. Draw the circle like this. Okay, so first you have to draw the circle. Later, if you draw the circle like this, then this portion is for optic now. This is for optic now. Just you can draw like this. Well, the nerves are reaching to the brain. After that, the front portion is for cornea. bulged portion, front portion. So exactly you can see. So you can observe this portion. Okay. Then you can take like this and you can observe. This is the cornea, somewhat bulged surface. This is a bulged surface. Understood or not? Like cornea and if you draw optic now, cornea and optic now, if you draw, that's enough. Then eye diagram is almost over. And a lens, you have to draw the lens here. You have to draw the lens. So what is that lens name? Convex lens. What is that lens name? Convex lens. So convex lens is also known as converging lens. Sir, why you are saying convex lens is a converging lens? Whenever light falls on it, whenever light incident on it, those light rays will be converged and make it falls at principal, make it falls on principal axis, or like on focus. If the light rays are coming from infinity, okay. So it converges the light rays. It converges the light rays. So that's why this is called converging lens. And that will be connected to the eye like this. So I'm connecting like here, like this, like this, like this, like this, like this. Understood or not? So I'm connecting like this. And here also I'm connecting like this. Okay, so like this you have to draw the eye diagram. Understood? That is eye diagram. The frontal layer, protective layer of the eye is called cornea. The frontal layer and the protective layer of the eye is called cornea. Okay, so we'll discuss parts wise. Cornea is the frontal layer, protective layer of the eye where most of the refraction takes place. It's like a gate. So whenever people are entering into the house, there is a gate is there, right? So it's like that. Okay. So it is thick layer, protective layer. Most of the refraction takes place. We know that refraction. What is the refraction? The path of the light changes when it is moving from one medium to another medium. The bending of the light takes place and it is moving from one medium to another medium. Refraction of light takes place. Understood? So when light is passing from rarer to eye, so that is nothing but denser. So most of the refraction takes place. Most of the refraction takes place at cornea. And most of the refraction takes place at cornea. Understood? Yes. Now, and one more thing, that is a cornea, right? Next one here you can see, this is the aqueous humor. Aqueous humor. Aqueous humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a hi. So how are you? So aqueous humor is a jelly type liquid present between eye lens and cornea. Okay. Hello, hi. Welcome to the class. Welcome to the class. Yes. So aqueous humor. Aqueous humor is a jelly type liquid present between cornea and eye lens. And coming to the next one, this is the iris. Iris. So and also here also iris will be there. This both portion we can say this is the iris. So this portion, these two. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. Understood? And people, so where is the people? People is here. This is the people. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. Cornea is the frontal layer, protective layer. Cornea is the frontal layer, protective layer. Most of the refraction takes place at this part. Aqueous humor is a jelly type liquid present between cornea and eye lens. And iris is a dark muscular diaphragm. So we are talking about iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. People is there, right? People. So this is the people. This is the people. These people will control and regulate the amount of light entering into the eye. Okay. So that's enough. Now you can observe. And coming to the eye lens. This is the eye lens. Eye lens. Eye lens is a convex lens, converging lens. When light falls on it, it converges the light rays and make it falls at retina. Whenever light falls on the convex lens, it converges the light rays and make it falls at retina. Okay. And coming to the this one. So ciliary modules. These are ciliary modules. Ciliary modules. Ciliary modules. And these are also ciliary modules only. Ciliary modules. Sir, what about ciliary modules? Ciliary modules are nothing but. So normally you can observe if you want to see nearby object or far, as well as far object. If you want to see nearby object as well as far distance object, what you will do? So we can zoom it or zoom out like that, zoom in like that. We want according to the object distance. In mobile we can do it. But in normally our eyes are adjusting itself. So if you want to see near distance object, automatically we can able to see. When you want to see far distance object, immediately we can able to see in the bright light, right? So depends when you enter suddenly from bright light to dark room, it depends. So that time it will take time to adjust to the light, right? Ciliary modules will adjust its, okay. That is a different scenario. But normally we can able to see nearby object as well as far distance object. If you want to see nearby object, we can able to see. At the same time, if you want to see far distance object also, we can see immediately, right? So who is the responsible for this? Who is the responsible person for this? Who is the responsible part? Here is ciliary modules. Okay. So here is ciliary modules are responsible part to adjust its curvature of the eye lens. Adjust its curvature of the eye lens. Ciliary modules will adjust the curvature of the eye lens so that eye lens will adjust its focal length. Ciliary modules will adjust the curvature of the eye lens. Eye lens will adjust the focal length so that we can able to see nearby object as well as far distance object. Nearby object as well as far distance object. Okay. So here, and eye lens will adjust its curvature. Eye lens will adjust its curvature. Eye lens will adjust its curvature and also its focal length. It adjusts focal length so that we can able to see nearby object as well as far distance object. And here is one point, that is power of accommodation. What is power of accommodation? Ability of the eye lens to adjust its focal length. Ability of the eye lens to adjust its focal length. Okay. So to allow the light inside of it. Ability of the eye lens to adjust focal length to allow the light inside of it is called power of accommodation. So convex lens is adjusting focal length so that light will enter. That ability is called power of accommodation. That is called power of accommodation. With the help of ciliary muscles. With the help of ciliary muscles only. With the help of ciliary muscles only, convex lens adjusting focal length. Okay. So that light will enter, those light rays will converge and make it falls at retina. We'll talk about retina. Now we will discuss about aqueous humor. Aqueous humor is a jelly type liquid present between eye lens and retina. So here you can see these are the optic nerves. Optic nerves. These are the optic nerves. So here you can observe these are the optic nerves. Optic nerves. Optic nerves. Nerves. Optic nerves. Understood or not? These are the optic nerves. These are the optic nerves. Optic nerves. Optic nerves. Optic nerves. Clear? Optic nerves. And this entire portion from lens to retina, this entire portion is filled by vitreous humor. Sir, what is the use of this one? Vitreous humor is a jelly type liquid present between vitreous humor is a jelly type liquid present between eye lens and retina. So here is the retina. This is the retina. Okay. So vitreous humor is a jelly type liquid present between eye lens and retina. Okay. So it provides sufficient force and pressure to maintain that shape. Okay. So it provides. Okay. So now you can observe. Now you can observe. So, vitreous humor. Vitreous humor is a jelly type liquid present between eye lens and retina. So, this is completely filled with vitreous humor. Vitreous humor. I hope it is very clear. Vitreous humor. Understood? Vitreous humor. So, it maintains sufficient force and pressure. It gives sufficient force and pressure to maintain that shape. And coming to the next one, retina. Retina is a light sensitive screen. Retina is a light sensitive screen where light rays will meet at that point. Where light rays will meet at that point. Understood? So whenever light rays are converging, after that those light rays will meet at retina. So at retina there are two light sensitive cells are there. Those are rods and cones. Those are at retina, these are rods and cones are there. At retina, one is rod, another one is cones. Rods and cones, these are light sensitive cells. Light sensitive cells. Rod sensitive identify the intensity of the light. Cone sensitive identify the color of the light. Rod sensitive identify the intensity of the light. Cone sensitive identify the color of the light. Okay, so I hope it is very clear. Now you can observe this is the optic nerve. Optic nerve. Optic nerve will nerves. Those nerves. Through the nerves, whatever the image is formed at retina. What type of image will form at retina? Real and inverted. What type of image will form? Real and inverted. Yes or no? Real and inverted image will form at retina. Real and inverted image will form at retina. Understood? Real and inverted image will form at retina. Okay? Yes. So that will be converted in the form of electrical signals. that will be converted in the form of electrical signals. So that will be converted in the form of electrical signals. Understood or not? Electrical signals. So you can see here, this is the optic nerve. Optic nerve. So what type of image will form? Real and inverted. That too 2D image. That will reach to the brain. That will reach to the brain through optic nerve. Through the optic nerve, whatever the image is formed at retina, that will reach to the brain through optic nerve. Through optic nerve. Understood or not? Through optic nerve it will reach. So normally whatever we are seeing, that is 2D image. So that electrical signal will reach to the brain. Brain will add the additional information. Brain will add the additional information, that is how much far it is, how much distance it is, okay, how far from us the object is placed, how much the water is filled in the beaker, like that, everything it can be identified. Everything it can be identified. Understood or not? So I hope it is very clear. So brain will add that additional information. Brain will give that additional information. How much distance the object is placed, the water is placed, how much the water is filled in the beaker, everything it will be. Everything it will be. Understood? So now this is about parts and function. Human eye, parts and function. Human eye, human eye, human eye parts and function. First one, cornea. Cornea is the frontal layer, protective layer of the eye. Most of the refraction takes place at cornea. And coming to the next one, so aqueous humor is a jelly type liquid present between cornea and eye lens. So it provides sufficient blood and nutrition to the central cornea. And coming to iris, iris is a dark muscular diaphragm which controls the size of the pupil. Pupil will control and regulate the amount of light entering into the eye. And eye lens. Eye lens is the convex lens. Whenever light falls on it, it converts the light rays and make it falls at retina. So retina. Okay, so at retina you can observe. At retina, light sensitive cells are there. Those are rods and cones. Rods identify the intensity of the light. Cones identify the color of the light. Okay, rod can sense the intensity of the light. Cone can sense the color of the light. So I hope it is very clear. This is about human eye parts and their function. So now I will discuss about refractive defects. There are three refractive defects. There are three refractive defects. Understood or not? Those are, so myopia, hypermetropia and presbyopia. Myopia, hypermetropia and presbyopia. Okay, so what is myopia? Myopia is nothing but the person who has myopia can see nearby object. He can't see the far distance object. The person who has myopia can see nearby object. He can't see the far distance object. Okay, but between 25 to infinity he can see. That is the far point of myopic eye. Far point of myopic eye. Okay, so check once here. So here this the person. Understood? I hope you can see this the 25 centimeter and this one is the infinity 25. But between 25 to infinity you can see that is a far point of myopic eye. Far point of myopic eye. I hope it is very clear. What is that? Far point of myopic eye. So he can see 25 centimeter, but he can't see infinity. But between 25 to infinity, you can see that is a far point of myopic eye. Far point of myopic eye. So I am taking here this the diagram. I'll draw the diagram. Just check once. So I am taking here like this. You can observe. So this is the convex lens, and here I am taking like this. This is the far point, this is the near point, and this one is the far point. Near point is 25 centimeter, far point is. So for myopic person, the far point is less than infinity. For myopic person, the far point is less than infinity. Understood? So here it will be. If the light rays are coming from this point, the light rays will meet at retina. So I am taking here. If the light rays are coming from this point, the light rays will meet here. The light rays will meet here like this. Understood or not? Like here. So you can observe. These light rays will meet here. So far point of myopic eye. Far point of myopic eye. Far point of myopic eye. Okay. So now myopic eye. So you draw that. So myopic eye is nothing but if the light rays are coming from infinity, where those light rays will meet. If those light rays are coming from infinity, where those light rays will meet, so we'll see that one. Okay. So here you can observe. I am taking like this. I am taking like this. So here you can see. So this is a convex lens. This is a convex lens. And here you can observe. So this is the near point and this one is the far point. Near point and far point. If the light rays are coming from infinity, where those light rays will meet? In front of the retina. So here you can observe. So light rays if they are coming, so you can see those will become parallel to the principal axis. Those light rays will meet. So in front of the retina like here. Okay. So you can observe this one. So these are the dotted lines. These are the dotted lines. Near point and far point. This is about myopic eye. Myopic eye. Myopic eye. So I hope it is very clear. Once again, the person who has myopia can able to see near distance object, but he can't able to see the far distance object. The person who has myopia can able to see near distance object, he can't able to see the far distance object. For that correction of myopia, we are using concave lens. But one thing, between 25 to infinity, somewhere in middle he can able to see. That is a far point of myopic person. So there is a diagram here. Far point of myopic person. This is a myopic eye. Now the correction. So correction part. Coming to the correction part, if the light rays are coming from infinity, so I am taking like this. Okay, so you can observe. You can observe here. This is a convex lens. And here you can observe. So what lens we are using? So which lens we will use to correct the defect of myopia? Concave lens. So dear students, please do like, share and subscribe to Student the Brand. So do like, share and subscribe to Student the Brand and share to our friends, ask our friends to join to the class. So the light rays are coming like this. This is the near point and this one is the far point. If you like the content, if you like the explanation, so do like, share and subscribe to Student the Brand, right? So after refraction, those light rays will meet at here. After light rays, those light rays will meet here. Okay, so like this. So if you are extending the light rays, the dotted lines will meet at F. So here you can see those light rays will meet here and here also. So what is this one? What is this one? Correction of myopia. correction of myopia. Correction of myopia. Okay, myopia. So if the light rays are meeting at retina, then those light rays, then we can able to see the object. If the light rays are meeting at retina, we can able to see the image. If the light rays are not meeting at retina, we can't able to see. So once again, you can observe here. So the person can able to see near distance, he can't able to see infinity. But between 25 to infinity can see that is a far point. So that is a far point of myopic eye. The light rays are coming from far point. Those light rays will meet at retina. And coming to the next myopic eye, if the light these dotted lines represent light rays are coming from infinity, those light rays after refraction, those light rays will meet in front of the retina. So as I mentioned, the light rays will meet at retina. We can able to see, but those light rays are meeting in front of the retina only, right? That is a myopic eye. And coming to the correction of myopia, if parallel lines are coming after refraction, those light rays are diverging. Here you can observe these light rays are diverging, and again, so after falling on convex lens, converging. So after that, those light rays are meeting at retina. Understood or not? This is the correction of myopia. So this is about myopia. So now we'll discuss about hypermetropia. Hypermetropia. So myopia song is myopia. So the person can able to see clearly near point, he can't able to see the far point. For the correction we are using concave lens. Okay. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using bro. What bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So myopia, near distance we can see, far distance we can see. For that correction we are using concave lens. Understood? So for the correction of myopia we are using concave lens. Next one, hypermetropia. Hypermetropia, hypermetropia, hypermetropia. Na 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 So here we are taking near point. So the person who has, this is hypermetropia. 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 So here you can observe this the person. Understood? The person who has hypermetropia can see the far point, but he can't see the near point. The person who has hypermetropia can see far distance, he can't see the near point. But between 25 to infinity, in middle he can able to see. That is near point. Near point of hypermetropic eye. Near point of hypermetropic eye. So here So if the light rays are coming, so N is normal near point 25 centimeter. So N dash is the near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Hypermetropic eye, hypermetropic eye, hypermetropic eye, hypermetropic eye, hypermetropic eye, hypermetropic eye, hypermetropic eye. Okay, if the light rays are coming from this point, light rays are coming this point, those light rays will meet here. Those light rays will meet here, meet here, meet here, meet here, meet here. So what is this one? Near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Near point of hypermetropic eye. Understood or not? So do like, share and subscribe to Student the Brand. If you like the content, if you like the channel, if you like my explanation, don't forget to click on bell icon. Then you'll get notification of live classes. Understood or not? Just click on like button and bell icon. And if you like the content the most, click on subscribe button. Stay with us. Okay, so near point of hypermetropic eye. Next one. No, 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 no. No, 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 no. No, 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 Dun, 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 dun. Na, ni, na, na, ni, na. Na, 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 ni, na, na, na. Okay, if the light rays are coming from near point, those light rays will meet beyond retina. So I'm taking here one light ray, another light ray I'm taking like this. After refraction, those light rays will meet here. Those light rays will meet here. Understood or not? After refraction, those light rays will meet here. So what is this one? Hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Now we will do correction part. Coming to correction part, so as I mentioned, so this point you can't able to see. So there is a 25 centimeter. If the light rays are coming from this point, those light rays will meet beyond retina. So that's why you can't able to see this point. But if the light rays are coming from this point, you can able to see. That is the near point of hypermetropic eye. Now coming to the correction part. Correction part. Okay, so you can see here like this, and you can so those light rays will here. I'm taking this a convex lens. This is a convex lens, and here I'm taking here. So this is a near point. So what lens we'll use? Convex lens. This is a convex lens. The light rays are coming, converging, again converging. The light rays again converging. So the light rays again converge and make it false at retina. Those light rays will meet at retina. Understood? So you can observe. So this is N and this one is N dash. Those light rays here, those light rays. So you can observe here those light. This is N. Understood? I hope it is very clear. So this is about correction of hypermetropic eye. Correction of hypermetropic eye. Hypermetropic eye. Understood? So is it clear? So if you have any doubts, let me know. I hope it is very clear. This is about myopia and hypermetropia. Myopia and hypermetropia. Next, so we'll discuss about now we'll discuss about presbyopia. Actually, presbyopia is nothing but the person can't able to see near distance as well as far distance. Okay, so he can't able to see near distance object as well as far distance object. For the correction of presbyopia, we are using concave lens. Sorry, bifocal lens. So concave lens upper portion, convex lens lower portion. Bifocal lens. Presbyopia we are using bifocal lens. Understood? Upper portion is concave, lower portion is convex. Okay. Coming to the cataract. Cataract. So few members can't able to differentiate the colors. Okay. So genetic order sometimes because they can't able to identify the colors. Okay, so there are few members, so okay, they can't able to identify differentiate the colors. That is called color blindness. Okay, so now cataract, a milky and cloudy will form on our eyes. Okay, so that can be corrected by cataract surgery. Okay, so automatically we can remove that defect. And coming to the next one, that is astigmatism. Astigmatism is nothing but the person can't able to differentiate the horizontal lines as well as vertical lines. So it depends on the person. So which colors generally? Okay. Thoda aata. So completely I can't able to speak, but I'm trying to speak. Okay, then come to the point. Astigmatism. Person can't able to differentiate the horizontal lines as well as vertical lines. So by using suitable cylindrical lens, we can able to correct the defect. Okay. Yes. So now we can go for refraction. So I'm taking this the prism. And this is the prism. When light passes like this, so splitting of white light takes place. 1, 2, 3, 4, 5, 6, 7. Okay, na? So splitting a white light into 7 colors. Splitting a white light into 7 colors is known as dispersion. So those colors are violet, indigo, blue, green, yellow, orange, red. 1, 2, 3, 4, 5, 6, 7. Okay, so violet, indigo, blue, green, yellow, orange, red. Understood? So now you can see those 7 colors will form. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, Vibgea. Violet, indigo, blue, green, yellow, orange, red, Vibgea. So splitting a white light into 7 colors. Splitting a white light into 7 colors. Splitting a white light into 7 colors is known as dispersion. Dispersion. Violet, indigo, blue, green, yellow, orange, red. Okay. So violet deviate the most, red deviate the least. Okay, so that's why bottom violet, at the top right. Understood? It depends on wavelength, refractive index, and different. Okay, so wavelength and refractive index. So next one. So actually Newton sent the white light through prism. He split the colors. He split the white light into 7 colors. So in lower classes you can observe. In the lower classes you can check. In the lower classes, so you can paste all. In the lower classes you may observe that. So that is. So on the disc, if you paint all the colors and rotate it, okay. If you paint all the colors on the disc and rotate it, then what happens? So it appears as a white color. So completely white. So you painted all the colors on the disc. When it is rotated, the outcome is white light, because all colors will be mixed and comes out as a white light. Okay. So here also Newton sent the white light on the prism, split into 7 colors. Still he further want to split the colors. He placed a normal prism like this, but he couldn't get. Okay, so he could not split the colors. So what he did? He placed inverted position of the prism near to the first prism. So this is the first one and this is the second one. Okay, so second one. Understood? First and second. So when white light passes, when you send the white light like this, so those colors will be split into 7 colors. Again those colors will be combined and comes out as a white light. Comes out as a white light. So here it is the, what is this one? Source. Source, that is white light. White light. And coming to here, this is the screen. On screen you can get white light. On screen you can get white light. Understood or not? So violet lower and red is at top. Violet is at the bottom and red is at the top. Okay. So I hope it is very clear, right? Next one you can observe. This is the recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of spectrum of white light. Understood? Sir, where did we get the rainbow? How can we get? So normally you can observe the rainbow will be appeared in the sky. Yes, sir, you can see the rainbow in the sky. So how it will form? What is the phenomenon involved in the formation of that? Okay. So by what we can get that rainbow? You can send the normally if the light passes through the water drop, if the light ray is passing through water droplet, so you can observe when light passes through the water droplet like this, that light split into 7 colors. White light split into 7 colors. Again, those 7 colors will comes out. You can observe here. Understood or not? So you can check here. This is the white light. Whenever it falls on the, whenever light ray falls on the water drop, it split into 7 colors. Those 7 colors will reflect internally. Internally, reflection takes place and comes out as a rainbow. So, what is the phenomena involved in the formation of rainbow? So, the phenomena involved in the formation of rainbow is, first one is refraction. Second one is dispersion. And third one is internal reflection. First one is refraction, dispersion, internal reflection. When light ray passes, when light rays passes from air to water, refraction takes place. So at the surface, at this position, dispersion takes place, splitting of white light into 7 colors. Those 7 colors will be reflected internally. So internal reflection takes place, then comes out as a rainbow. So the phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Once again, when light ray passes through the prism, split into 7 colors. The splitting of white light into 7 colors is called dispersion. And those 7 colors will form like a band on the screen is called spectrum. And here, so recombination of spectrum of white light passes through the prism, split into 7 colors. Those 7 colors again falls on the prism, that comes out as a white light. Okay. And coming to here, when light ray passes from rarer to denser, split into 7 colors. Those 7 colors. So refraction. Okay. Normally refraction. First refraction takes place, then dispersion takes place, then internal reflection. So this is the phenomena involved in the formation of rainbow. Understood? So refraction, dispersion, internal reflection. And coming to the next one, atmospheric refraction. Sir, what is atmospheric refraction? So normally, when your friend is standing another side of the fire. Okay, I'm standing here. Okay, so you're standing this side. So in the middle, fire is there. Okay, another side your friend is standing. Okay, suppose. So when you are seeing through the fire, so your friend image appears fluctuating, appears flickering, appears wavering. Sir, what is the reason? When light ray passing from rarer to denser, the refraction of light takes place. So because of that reason, the image of the person appears to be flickering, wavering, and blinking. Understood or not? Due to refraction of light. That too, atmospheric refraction. Due to atmospheric refraction, the person image appears flickering. That is in the small scale. Coming to large scale, twinkling of stars. So, how stars will twinkle? What is the reason? Because of atmospheric refraction. Light rays coming from star, right? So it is so far from the earth. So it is the light rays keep on changing its direction. When it is keep on changing its direction, by the time it reaches to our eyes, so the star appears twinkling because There are so many refractions. There are so many refractions taking place. Understood or not? So here you can observe the person is here. Okay, the person is here, and this the star. This the star. So the keep on refraction takes place. So refraction taking place by the atmosphere. Refraction is taking place by the atmosphere. The star appears here. The position of the star is here. This is the apparent position and this is the actual position of the star. Okay. So due to atmospheric refraction, the position of the star rises up. Okay. So the star position. And coming to the next one, advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. So this is the earth, okay, and atmosphere. This is atmosphere, earth, the atmosphere. The person is standing over here, okay, the person is standing over here, and so that is origin. So here is the origin. This is the atmosphere, earth atmosphere, earth atmosphere. The sun appears here, okay, this is the sun position. So the sun position. So when light is coming from the sun, when it is entering into the atmosphere, so the position of this sun appears here. The position of the sun appears here. Understood? So this is the apparent position. This is the actual position of the sun and this is the apparent position of the sun. So normally when light ray is coming from the sun, due to atmosphere, refraction of light takes place. So the sun position appears above the origin. This is the origin. Origin. Understood? So this is the origin. Due to atmospheric refraction, the sun's position appears above the origin. Sun's position appears above the origin due to atmospheric refraction. Okay? I hope it is very clear. Understood? So when it is entered into the atmosphere, refraction takes place. So it appears here. Advanced sunrise and delayed sunset. So 2 minutes. 2 minutes advanced sunrise and 2 minutes delayed sunset. Due to atmospheric refraction. Due to atmospheric refraction. And one more thing. During morning time and evening time, sun appears red color. So what is the reason? Due to scattering of light. Due to scattering of light. Okay, so I'll explain scattering of light clearly. Just check once. Scattering of light. What is scattering of light? Scattering of light. Scattering of light. Scattering of light is nothing but the re-emission of light in all directions. The re-emission of light in all directions with a different intensity. So I am taking this light. So here is the particle. Okay. So the wavelength. What is the wavelength? Wavelength is nothing but the distance between this the crust, trough. So the distance between two consecutive crust is called wavelength, and distance between two consecutive trough is called wavelength. Distance between two consecutive crust or two consecutive trough is called wavelength. When the light is coming and incidenting on the particle, the wavelength of the light incidenting on it, so that wavelength is comparable to the particle size. When light is incidenting on the particles, this is the particle. So particle, you can see this is a particle and this one is the light. Okay, whenever light is incidenting on the particle, so the wavelength of the light incident on the particle, that wavelength is comparable to the particle size, then the particle will absorb the light. The particle will absorb the light and emit in all directions. Particle will absorb the light when? So wavelength of the light is comparable to the particle size. Then it will re-emit in all directions with a different intensity. So the re-emission of light in all directions with a different intensity is called scattering of light. What is the condition? So wavelength of the particle is comparable to the size of the particle. Wavelength of the light. Wavelength of the light is comparable to the size of the particle. Wavelength of the light is comparable to the particle size. Then the particle will absorb the light and emit in all directions with a different intensity is called scattering of light. Is called scattering of light. I hope it is very clear, right? Yes. So coming to the next one. Next one we will discuss, that is so sun appears blue color, sun appears red color, sun appears, so during noontime it appears white color, sky appears blue color, sun appears or sky appears reddish color in the morning time and in the evening time, and in the normal day it appears blue color and noon time it appears white color. So related to colors, if it is related to color, that is scattering of light. If it is related to color, that is scattering of light. What is scattering of light? The re-emission of light in all directions with a different intensity. When light comes from the sun, because of the atmosphere, the scattering of light takes place. Because of the atmosphere, scattering of light takes place. Okay, only that particular colors it will be visible to us. In the remaining time, whenever light comes, okay, so from the sun, because of the atmosphere, scattering of light takes place. Okay, so blue light scatters more, that's why it appears blue color. Even deep sea also it appears blue color, because so blue color scatters the most. And one more thing, so during morning time and evening time it appears red color. Why? Sky appears red color. Why? Because red color has more wavelength compared to the remaining colors. Red color has longer wavelength. Okay, so red color has longer wavelength. It travels long distance compared to the remaining colors. So as soon as enters if the light enters from the sun into the atmosphere of the earth, because of the atmosphere, all colors will scatter away. Only red color will travel long distance. That's why morning time and evening time, so sun and the sky appears red color. You can observe it appears reddish. Okay, due to scattering of light. If it is related to colors, so you have to think that is scattering of light. It is related to position, apparent position. So sun appears so above the origin and a star appears little bit above position. It is due to atmospheric refraction. Coming to the Tyndall effect, the path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through colloidal solution. So by the colloidal solution, scattering of light takes place. So colloidal particles will scatter the light in all directions with a different intensity. That only it will scatter the light. That is the reason we can able to see the path of the light clearly. You can take a glass of lemon water and send the laser light. We can able to see the path very clearly, because so what are the particles are present in that lemon water that will scatter the light. That will scatter the light. Okay, by that we can able to see the light clearly. Okay, so at that reason it's, and coming to the early morning, if you open the windows, okay, early morning if you open the windows, so a beam of light falls, we can able to observe the dust particles are flying due to scattering of. Okay, so that is a Tyndall effect. Okay, so I hope it is very clear. This is about a human eye parts and function. So we discussed all the points. So human eye in colorful world. In that human eye parts and function, refractive defects, myopia, hypermetropia. After that, refraction through prism and a recombination of spectrum of white light, and rainbow formation by water droplet, atmospheric refraction, and scattering of light, Tyndall effect. Okay, so all those points we discussed. So thank you so much for joining and attending and listening my class. So if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand. So share to your friends, ask your friends to join to the class. So exams are coming up. We are discussing important points. So once you go and check the channel, go and visit the channel. There are many videos are there related to CBSE Grade 10 physics. So still we are going to discuss so many points. Come to the live classes, attend the live classes. So we will discuss the topics with practice session too. Okay, we'll do practice also based on particular problems coming to electricity, light reflection, refraction, and coming to human and colorful world and magnetic effects of electric current. Concepts will discuss briefly and in depthly. Okay, so thank you so much. We'll see you in the next class. Do attend the live class. This is your Shiva sir. We'll see you in the next class. Thank you.